So my name's Paul. I work at a company called System Initiative. This is a talk about the AWS Cloud Control API. Anyone use Cloud Control? 1, 2, seriously? Like, I've come here and nobody, Matteo, hey! Nobody knows this fucking API. All right. Okay, cool. So this is going to be a journey, right? So firstly, I have to apologize for a few things. I used to work at Terraform. I used to be on the core Terraform team. A lot of the bugs that you face today were probably due to me. Okay, I left there. I went to another company called Pulumi. That's also probably my fault, so I apologize for that in advance as well. I have been an infrastructure engineer for a long time now. I'm like fucking old. So like it's a wild ride in infrastructure at this moment in time, especially with the infrastructure as code circles. So like things are changing, okay? I know I work at a company called System Initiative. I'm the director of product there. Who would ever have given me the idea of a director of product? That's madness. But it's the funnest job in the world, okay? I work with an incredibly smart bunch of engineers. Sales pitch over, okay? If you need to talk to me, my email's there. Please get in contact. So if you don't know, you more than likely don't know because it's a new tool. System Initiative is a tool that sort of allows you to be able to create living architecture diagrams that in the background talks to AWS back and forward. It's a real-time polling system that talks back and forward to AWS that allows you to have a visual interface, okay? It's based on digital twins, okay? So you have a model and you have a resource in the real world and you have data that syncs them. You have actions that sync the data between each other, okay? A way to explain that is you would not take a Formula One race car and you would not make a change and put it straight onto the track. That would be the worst possible thing in the world. You actually have to build or I used to use the idea of an airplane simulator. Worst fucking example about like that because they're just falling out of the sky. But you would not change like things in a Formula One car without actually building a simulator and testing those simulations and understanding what's happening. We're trying to do the same thing with infrastructure. For us, it's not about using an API. It's got no abstraction on Terraform. It's no abstraction on Pulumi or anything like that. It's an automation system. Okay, it's a platform for building automation on top of. So it can talk to any API, any CLI, blah, blah, blah. It currently targets AWS, which is why I'm here. Not exclusively AWS. There's a lot of other things in there, but part of the journey of this talk is about AWS, of course. And like you can kind of see where you have this representation of like an AWS asset, and then you have like all of the different pieces like image ID, instance profile, blah, 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 right? We'll talk through that as we go. Now the challenge for us, firstly, Terraform users, great. Pulumi users, less. All right, perfect. I don't mind. I don't mind. So the main thing is we all know based on the repositories that exist in the wild, keeping up with the cloud APIs is painful, okay? You have to wait sometimes a number of weeks, days, months, whatever, before a resource is available in that infrastructure code provider. That is not the fault of the infrastructure as code provider. Very important I tell you that, okay? I used to be this ridiculous geek who used to try and beat AWS to release changes to the Terraform provider. Okay, I was literally that person. Okay, and I still hold the record that I beat AWS to the NAT gateway resource that Terraform released it 2 days before AWS did. And it's because all of the teams inside AWS didn't have a standard. Okay, each team had like some people targeted the CLI, some people targeted the SDK, some people targeted blah, 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 blah. Terraform's built on top of the SDK. So you have to, Terraform has to wait until the SDK is updated before it can build support for something. Then you've got to wait for somebody to add that support, whether it's an internal user of Terraform or the core team, or whether it's a community member or whatever. Okay, so there are a number of factors why it's painful to keep on top of the APIs. Okay, and we know that there are workarounds. Okay, there are workarounds. Okay, you have the Terraform Cloud Control API. Okay, it's been in beta for maybe 3 years because of the fact that the stability in those APIs is not as like useful as others. Now, In September 2021, the lovely people at Amazon released what's called the Cloud Control API. Now, I know this API incredibly well because during that period of time I was working at Pulumi, I was an engineering manager there, and my team took on the work to build the new AWS native provider at Pulumi. Okay? Now, for those who don't know Pulumi is not built on top of Terraform by any stretch of the imagination. That is a misnomer. Okay? Pulumi is able to use Go to go to the Terraform providers and pull the schema and build its own provider. It is complete independent. It is not using Terraform under the hood in any way, shape, or form. The latest releases of Pulumi means that you can interact directly with the Terraform providers so that we didn't have to build that bridge anymore. Now, back in 2021, when AWS released this Cloud Control API, we kind of thought it would be awesome if we could build day one support at Pulumi for Cloud Control. Now, of course, an API was released by Amazon. Not all teams within Amazon caught up and were able to stay up to date very fast. Okay, so life has been changing, and since I left Pulumi, I don't even remember when I left now, like maybe 2022 sometime. But like since then, like the Cloud Control provider has been gaining huge changes, okay? Like there is a standardization within AWS. I talked to one of the product teams there last week, or 2 weeks ago, about the fact that most teams are being forced to move on to the Cloud Control API. Now, the interesting thing about the Cloud Control API is it does not support everything right now because a lot of the old systems don't have that level of support. Now, its definition here is it would try to create this unified set of APIs for CRUD. Okay? So it wanted to have that same like API that went across everything. And it was like an API abstraction on top of the individual services themselves. Okay, so each service would be able to plug in to the Cloud Control API. They didn't have to write anything specific because of the way it's architected. It is very interesting. Now, its core capabilities is you could create, you could get, you could update, you could delete, you could list, but you could also get progress tracking. Okay, now we all know eventual consistency is this monster in the cloud, and that's what Amazon did to help us solve eventual consistency. Okay, they gave us this motherfucker. They gave us this API that we could actually track the request and we could understand it. But they also gave us the ability to understand types, to give us, to discover what was in the cloud as well. Okay, so this is where things started to go a little bit better. For us at System Initiative, it was the perfect looking API that we could model against, or so to speak. Now, if you don't know, you could kind of create, like run an AWS cloud. This is using the CLI. This is not using the SDK. I'm like old school. I go straight for the CLI these days. I'm like back to my roots. Okay, but like you gave it a type name and then you give it a desired state. Now, for those who have ever used CloudFormation, the desired state looks identical to CloudFormation because it uses the CloudFormation schema. Now, the fact that it uses the CloudFormation schema means it's incredibly well defined. Okay, it may not be the best schema in the world, and some people may groan when they hear CloudFormation, but it is incredibly well defined. The specification itself is very good, okay, because it has a unified structure and it has a unified shape to every API operation. You have a create operation, you have a patch operation or an update operation, and you have a get operation. Okay, and the fact that it uses that specification means that it's quite ripe for automation. Now, what's that benefits of that API layer? Okay, so firstly, it's consistency. Okay, the same patterns will work across AWS services. Okay, each service does not matter as long as there is a CloudFormation specification for that service. It can plug into the Cloud Control API. Okay, which is why they're playing the long tail at this moment in time. And largely, there's a huge number of services in AWS that have been covered at this point, but there are some that are still playing catch up because they're the older services or services that are not like, designed for the get operations or the import operations. It is a reduced cognitive load, okay? What a mouthful of crap that is. All right, and what that actually means is you kind of have to just learn one API. Okay, you don't need to learn the API for DynamoDB and for EC2 and for S3 and for Route 53. You know the shape of the API, but you pass in different document shapes to it, and that document shape is based on the CloudFormation specification that links to the individual service itself. And of course, because the CloudFormation specification is well formed and it is well documented, it is quite simple to use. Now, this is kind of Amazon's future proof. Okay, this is their bet at being able to deliver systems faster and more consistently. Okay, now what I mean by that is I told you I was the nerd, the geek, who always used to try and be as I possibly could in order to deliver the Terraform resources for an individual service. And I told you that because the way a service team delivered it, some delivered it to the CLI, some delivered it to the SDK, some delivered it to the API, etc. That's why you find that in Cloud Control kind of makes this the future way of delivering systems in Amazon. Okay? Because all teams at Amazon kind of know that CloudFormation is the way forward, that they have to be able to deliver the system. Okay? Now, that's not saying that it's actually like they build the whole CloudFormation asset. The specification itself is the important part, and that specification works for CloudFormation itself, or it works for the Cloud Control API. Now, under the hood, CloudFormation itself is starting to use the Cloud Control API because it is a unification of how things work. Okay, that is why services are starting to be delivered more consistently in Amazon, because of the fact they have that unified layer, that API that allows them to do that. Okay, but it's program agnostic. That's the nice thing here. They don't need to go and build an SDK for JavaScript and an SDK for Rust and an SDK for TypeScript and an SDK for Python and all these different things. It's a specification that they can feed into a generator, and the generator will build the SDK directly for them. Okay, this is their ability to move faster and be able to drive things forward. And lastly, of course, it's automation friendly. It is incredibly declarative. We look at this. Create resource takes a type. Doesn't take anything other than a type, and it takes a shape of a document. Okay, this is very desired state style. This is very DSL-based style of being able to deliver systems. Now, this means it's going to work. It's going to be the perfect model to automate against, right? It's beautiful. It's like the best thing ever. No, it is not. Okay, I'm going to show you first thing what you actually have to do here. Okay, so let us. I'm not even joking you. A customer has just this minute asked me for a change to one of our CloudFormation specifications. Okay, so I thought it's kind of a cool thing to be able to show in a little bit how we do that. But effectively, you'll see my editor. Don't worry about the editor right now. That's not the important thing. So the lib, and we want to go to JSR, and we want to go to CFDB, and we want to have a look at the CloudFormation schema. Okay. So you'll see right here, these are not checked into GitHub, don't worry. Every piece of code I'm showing you here is open source, not proprietary. You can go and look at our repo, not the important part. Okay, but the interesting thing is that every part of the API, every resource in the API, there is a CloudFormation specification that you can go and download. Okay, that is a total thing. Somebody choose me one, give me a service. Guard duty, fuck, I bet that doesn't exist. All right, so let's see if we can find guard duty, okay? It does exist, I'm kidding. It actually does exist, all right, so. Which Connect? Actual Connect? I bet that exists as well. All right, so let's have a look at guard duty, because I do know that exists, because we do use guard duty ourselves internally. All right, so which one? Guard duty detector, filter, IP set, malware protection plan, which one? Which one? Okay, so the actual detector. Oh, no, not that one. All right, so the way that a CloudFormation spec works here, this is actually like the CloudFormation spec in here, right? So first it tells you like if this resource is taggable. Not all resources in AWS are taggable. Who knew? Not me. No, and some of them have different consistency of like different ways that you can pass that in. Like some of them have tag specifications. Not with the Cloud Control API, my friends. It is a consistent API that works across tags. It's like I work for Amazon. I don't work for Amazon. All right, secondly, you have a list of properties. Okay, these are the parts of the document that you build in. Each property has a type. Sometimes it is an array, and sometimes it points to a specific child type. Okay, so you have a very rich document that you can actually do this. Now this means, again, you can start to see it is a JSON file that you can serialize into a type and you can actually build on top of. Now, those lovely people at Amazon, I will stress that they're lovely people at Amazon. I've lost my window. Oh, they are. They're nice. They gave me free credit recently. I'm happy. Yeah, I am a cheap date. Let's put it that way. I am such a cheap date. Hey man, I'm okay with that. Free money, real money, it doesn't really matter. All right, so our attempt to ingest this Cloud Control API, we came back after Christmas. We sat down on the 4th of January and we were like, right, the problem at System Initiative we have is that right now we manually curate assets. Okay, it's a one-to-one mapping. Okay, and what we used to do is we used to use the CLI, and there is a flag that you can pass into the CLI called generate CLI skeleton. Okay, the best and worst thing ever. Okay, now it's great because it does give you a basic structure of what an AWS resource needs, but inside the CLI there's a lot of hidden black magic. Now what I mean by that is that sometimes when you create a resource by the CLI, under the hood in Amazon it's doing 2 or 3 or 4 things. Okay, it is glue that happens together. It is a syntactical sugar to be able to create resources. Okay, now in a system that is declarative and as a one-to-one, that is not a right thing to do. It makes it very difficult to understand what is actually happening. So our first attempt was very interesting because our first attempt was, right, let's take the CloudFormation specifications that we download, and by the way, there is a public S3 bucket that you can go to, and you can download these specifications and you can chop them up till your heart's content. Okay, our first attempt was, let's take these JSON files, let's download these JSON files, and let's create system initiative types. Now, of course, we built our own generator. I'll show you that generator in a second. Okay, it is not rocket science, I promise you that. And it literally uses JSON spec, okay, JSON schema under the hood, which basically allows us to map one-to-one. Okay, so we took those types, we downloaded them, and we were like, well, this is great, isn't it? And then we realized, actually, even though there's cloud formation specifications for 1,800 resources, not all of them are supported in the Cloud Control API. So we were generating all these assets and we were like, oh my God, this is the best thing ever. And then we were dragging those into our system, and when we ran the create action, AWS was like, no bueno, buddy. You can't do that. That's not supported by this API. And we were like, what in the actual is going on? Okay, so we introspected about what the hell was going on, and we find, of course, that you can find that there is a page within the AWS documentation, and there is a CLI command within the CLI that tells you what resources are covered via the Cloud Control API. Now, I told you it's consistent across services. It is not, because there are missing fucking spaces. Okay, and the fact there are missing spaces, I told you I'm going to swear, I'm sorry. The fact that there are missing spaces just means is the fact that different parts of the API are not covered. And of course, we also know that there are some operations within Amazon that don't have update operations existing with them, right? For example, you cannot change the CIDR block of a VPC because it is a fixed asset. And if you need to change it, you've got to like effectively schedule a recreation of your VPC. Okay, so the same sort of thing happened here. And we were like, right, we middle scratched a little bit and we were like, okay, this is kind of weird. Like, what do we do here? Like, you know, there's a couple of things. And we ended up in a situation where it was like a tariff was imposed on us. I love a little bit of political topical humor, okay? Yeah, 125% apparently. Anyway, so we went back to the drawing board and we were like, right, what can we do to be able to understand which pieces of the puzzle are created by the Cloud Control API and which ones are not? I shit you not. Our first attempt at like being able to take away the Cloud Control, the resources that are not controlled by the Cloud Control API, we ingested the HTML document and we found all of the pieces that were not included and we were like, matching, 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 not matching, throw it out. Okay. Now we went from 1,800 assets in System Initiative, we lost 500. Now that's not a like when I say it's not 500 full services. That's like sub assets and stuff like that. So for example, a sub asset inside CloudFront distribution, you have a cache behavior. Okay, and a CloudFront distribution can have many cache behaviors. So we would lose the equivalent of like sub assets plus top level assets. Now, as you can imagine, for the customers that were using us at that point, they were like, where's these assets going that you promised me? Okay, like you told me you have full coverage of the AWS API. Why is that going down like 500 resources overnight? And we're like, I don't know. Like, you know, so we were like, right, we needed a rethink. Like we actually needed to go back to the drawing board again. I'm like, no, I'm not talking that this is not years worth of work. We're probably the second week of work on this. Okay, this is not work. This has not been a huge level of lift and shift for us. It's really important to say that we've iterated our way to get to where we are today based on being able to move really fast on the fact that the Cloud Control API and the CloudFormation schemas are incredibly stable and they're well formed. We've been able to like move really, really quickly. But what we actually did in attempt 3 was we found a part of the Cloud Control the CloudFormation specification at the bottom had a handler section. Okay, and the handler section told you the permissions that were required by CloudFormation to be able to interact with that specification. Now, with 1, talking to AWS, and 2, the process of very intuitive detective skills, there was no fucking detective skills used, we were able to understand that this is certificate manager, private certificate manager certificates. We were able to see, based on the document that I showed you before, that the private certificate manager certificate had a create operation, a read operation, a delete operation. It didn't have an update operation. We were able to go, oh, this is like revelation, right? We were literally able to use the JSON spec to be able to see what parts of the Cloud Control API was included and what ones were not. Furthermore, if there was no handler specification, it was not supported in Cloud Control. They gave us the information, they just didn't tell us the information was available. Okay, and what that actually meant was we could start to make the decision about which parts of the system that we used. Now what I mean by that is, if it didn't have a handler section, we knew that actual CloudFormation itself can handle it because there is a CloudFormation specification. So we were like, let's do the worst possible thing that we could do. And anybody who wants to use these 25 or 30 services, let's make them use CloudFormation. So we actually made them use CloudFormation. And in our system, the output socket, which is like in System Initiative, data is transferred via sockets. Okay, so you have input sockets, which takes data from upstream, and you have output sockets, which passes data on to other pieces of information. And each socket is a function. Okay, think of it as like just a reactive graph that when you connect things and something changes at the top, it sort of runs functions the whole way down until it gets the intended output it needs. Okay, so we thought, wouldn't it be great if the output of the resource that everything can compose and build would generate a CloudFormation document, and then we would just pass that to a CloudFormation template, which would passes it onto a CloudFormation stack, and the world is not a better, well, it is a better place, but it's not the greatest place in the world. But it allowed people to be able to start modeling their different pieces of infrastructure. It allowed us to start modeling our infrastructure. One of the main services that Cloud Control API does not support is Route 53 record set. Okay? The fact that you cannot create records for Route 53 hosted zones via the Cloud Control API was causing me pain. We build our own SaaS with System Initiative. We dogfood System Initiative with System Initiative, so it's very important that we could actually build all of the different integrations that we needed. So we started to do that. Now, there are still a bunch of issues with what we're actually doing, of course, right? Because one of the parts of System Initiative is that we support what's called import and discovery. So if you have existing infrastructure that was created outside of System Initiative, you can import that, or you can go to AWS and you can discover what resources are currently in AWS. Okay? It's the golden promise that every infrastructure as code tool has made it for a while. It's what I used to tell people was the best way forward. You would have to find the specific ID when you're using Terraform and Pulumi in the CLI. Now you can actually just drag on a management component onto System Initiative Canvas, which is a VPC, give it some credentials and say, go and find me all of the VPCs. And it will go and bring them and it will create them on the canvas. It's how we did our own SaaS. Okay? Second thing is, not all, this was the most frustrating of the whole points. Okay? The get resource operation for Cloud Control API didn't always return the data that you needed. And we discovered our infrastructure and we imported our infrastructure and we were like, why is our launch templates don't have any data? And it's because the get resource operation for launch template doesn't bring in the data and you need to actually call a different API to get the data for your launch template. All it does is it returns you the default version and the latest version, nothing else. No use. Absolutely no use whatsoever. So we're like, okay, we need to do something about that. The next thing is we needed to be able to supplement data with overrides. Okay? Because Cloud Control is great for create, read, update. It's not very good for day two operations. Operations like refresh all of the instances in my autoscaling group, start my VMs, stop my VMs, reboot my VMs, etc., etc. Okay? Because System Initiative does all of that. That's what we pride ourselves on. It's an automation platform. So we needed to start thinking about the different ways that we could actually do this. Now, I'm going to show you the structure of, not that.
At least it's just your LinkedIn profile.
I mean, that could have been interesting, right? So yeah, the way that this was a situation, we started building this pipeline. And this pipeline means that there's a number of different things happening in here. Okay, so the first thing that we actually do is, I showed you that we download the JSON specs, the JSON files, and we start to chop those up. You can go to our repo, as I said, and you can have a look at what I'm actually doing in here. Okay, but the first thing is after we fetch our schemas, we generate our SI specs. Okay, now our SI specs, System Initiative specifications, have a number of steps that go with them. First thing that we need to do is we need to if there's any documentation links in the CloudFormation specifications that don't exist, we churn those out. The worst thing that you can possibly do for users is give them a link to documentation that doesn't exist. Okay, is an awful experience. So we go off and we check all the APIs and just make sure all it works. This is TypeScript, by the way. This is why it's fast to interact with. Okay, secondly, we'll talk about the inferred enums in a little bit, right? Secondly, we generate all of the output sockets and we generate, or we annotate all of the sockets. Okay, now what that actually means is that ARNs can connect to ARNs, strings can connect to strings, objects can connect to objects, etc., etc. There's some sophistication in our diagram that allows to do that. Then we start attaching actions being create, read, update, delete, import, discover, code gen, etc., lint, all these different pieces. Then we start generating some assets and etc., etc. Now, we know that as this is a generated API, we're going to get it wrong. Okay, that's just the nature of like automation. Okay, so what we actually did is towards the bottom, we introduced this idea where we can add asset-specific overrides. Okay, so I told you at the start of the talk that a customer asked me today to add a specific override that they can connect two pieces of information together in our graph. And how I did that is we go into this asset-specific overrides. Now, asset-specific overrides, it takes a type, okay? And that type is the name of the CloudFormation specification. A better example here would be AWS EC2 instance. Okay, so the first thing we do in AWS EC2 instance is I want to, for some reason, like we have a part of our system which passes user data around in like plain text. So the first thing I wanted to do is override that when somebody connected user data to an EC2 instance, our system needs to be able to run a function which base64 generates that, right? So I wrote this function which is called base64 encode user data. And what it does is it checks, is it base64 encoded right now? If it's not base64 encoded, the simplest function in the world is TypeScript, right? And then what we do is we generate like some function args. And the most important thing is we attach that function to a prop, and that prop is of type code editor. Okay, so we can start to be able to override and like build very specific patterns, and we can like add annotations, and we can like start to be able to do lots of different things. So, and here you can see I'm attaching a reboot operation, I'm attaching a stop operation, I'm attaching a start operation, etc., etc., etc. Now, when I run the CLI for this, like what you'll actually see is if I do deno run deno task run generate specs. Okay, the first thing that does is that actually goes off to AWS and it downloads all of the specifications, and you can see it actually tells me that Media Connect Flow has an unsupported format in their JSON spec. Okay, so 32 isn't a JSON spec, that should be a number, so we know. Then it builds all of the different pieces, and it says like 8 assets haven't been generated that are currently on the module index, which means that they have been deprecated by AWS in the past period of time since this ran. And then it tells me it built 1,358 out of 1,388, including 444 sub-assets. Now, that's like a load of crap output, but the most important thing is that generated some system initiative specifications that you can see here for how our system looks. Now, if I show you like AWS config application, then you can actually see this is the real generated API spec for system initiative, and it has the variants, it has the links to the documentation, the colors, what type it is, its funcs, it has any descriptions, etc., etc., etc. Now, for us, this was revelation. Okay, the fact that we could do this and the fact that we could override it means that I could go off and I could just now, 41 minutes ago, before this opened, okay, I ran this pull request, and that pull request, all it did was just add a socket annotation to WAF v2 WebACL association, and our pipeline turns around and says, hey, that's going to make a change to the socket, and what I can do is I can take this right here, and I can pass in a GitHub action that says diff, and it's going to show me in a second when the GitHub action runs of what the actual diff is. Now, you're not going to wait for that to happen, so here are ones that I created earlier. Okay, and in this case, you can see that this is a cron job that runs every single day, and we pulled in 4 new modules. This is EC2 root server. Okay, this is not available in Terraform yet. The reason it's not available in Terraform yet is not because it's Terraform's fault, it's because it's not in the SDK yet. And the fact that it's not in the SDK means Terraform cannot add it because they need it to go to the SDK. We were able to pick it up luckily because of the CloudFormation spec. And we're going to keep doing these, we're going to keep finding more and more and more pieces. But the interesting thing is is that based on that spec and that diff, I can actually be able to understand the differences in what this means. So this is a new prop that came in today. I didn't realize that root 53 resolver query login config did not support tags. It fucking does now. Okay, Amazon added support for it apparently yesterday. Great, so it's now supported. And so this is the level of detail that we can actually see, and we can understand, like, it's an input socket now for tags. The tags is an array. You can actually only create the tags. It means you can't update them. So tags are only on create, blah, 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 right? So we have this information and we can actually do this, and it's because of the fact that we had this API, this spec available for us to be able to do things on. Now, generative AI is a thing, okay? It is literally a thing. I promise I'm running out of time. I need like 4 more minutes, that's it, and then I'll stop. Generative AI is like this crazy thing out there that's like, oh my God, you see all these AI tools taking in like infrastructure as code specs. You've probably seen MCP servers and like all these different pieces being able to do it. They're not great for day 2 operations. They're brilliant if you ask them a question of, show me how I can create a VPC in Amazon and like set 3 public, 3 private subnets, because they don't really get all of the context of what's going on. So we tried to solve it using Gen AI, and we did. We got a little bit far, and we could say, generate me the schema for a root 53 record set, and then give me the create action, and give me the delete action, and give me the update action. But it was slow, and sometimes it got it. Most of the time it got it wrong. I'm not gonna lie to you. Most of the time it got it wrong. And sometimes it would give me 5 props. The next time it would give me 10 props. And then it would make some shit up. And then the next time you asked it again, you're like, but no, really give me the answer. It's like, all right, I'll take away the 2 that I faked. Right? And that's what happens with this Gen AI story. So it's not that Gen AI can't do this. It's just like you need to feed it the correct context. Now, when I say you need to feed it the correct context, we did actually do this. Okay, I'm going to show you one of our workspaces, and I'm going to go into the admin panel. And we did, let me refresh my app. And we wrote these monster prompts. We literally wrote these monster prompts, okay? And we gave it documentation to do things, and that was a prompt for one thing, and then we had another prompt for another thing. You can see it was just painful.
Was it Langflow?
Say again?
Were you using Langflow for that?
No, we're just using GPT-4o. Like we could have done this a number of ways. Like I'm sure DeepSeek would have made a better like Claude. Possibly so. Claude Sonnet 3.7 or Claude 3.7 is brilliant for this type of stuff. Now, when we did this, we weren't getting the best results, so we went back to the drawing board and thought again. Okay, but we did sprinkle a little AI magic. Okay, I'm not gonna lie to you. So we wrote a prompt that took the CloudFormation specification and is like, right, in System Initiative, you have drop-down menus for like different options that you can choose on props. So for example, the best known is ACL values on S3 buckets, read only, or public read, private read, like et cetera, right? So we were like, wouldn't it be really cool if we could take this well-formed like CloudFormation specification and pass in some information? That's the size of the prompt right there. Who knew that the ChatGPT options or the Lang chain ops out there were really good about CloudFormation specs? It's almost as though Amazon are building like their own tools, right, around AI. But yeah, so we were able to give it like a small prompt, and we were able to actually get really good data out of this, and we keep this, we cache this, okay? Only when the actual prop or the documentation has changed, we regenerate the AI. Because if I like want to run OpenAI across 1,400 assets every day, it's going to bankrupt my little startup. So I don't want to do that. So we want to actually cache it as much as possible. All right, last piece, okay? There is a pipeline. This pipeline runs every single day, okay? The plan is right now, we actually run it once a week. We're leaning ourselves into it. The fact that we have once a week, we got really good success. We're now running once a day, we're getting incredible success. So we're only ever a maximum of 24 hours behind the AWS API. Delighted with that. Absolutely delighted with that. But at the same time, you don't need to wait for a binary to like, System Initiative has like a different way of upgrading components and stuff like that. Our plan is to run it multiple times a day, 4, 5, 6 times a day, because the majority of the time it is a no-op. It is incredibly inexpensive for us to actually run that. But the most important thing is about putting those changes out into our users really fast. Okay, and all we got to do, we have a module cache. If something doesn't work or something's broken, we can really go quite fast, make that change and actually do it. If I go back to this API, or this GitHub action I wrote a pull request into, it tells me, it gives me the ability to understand all of the changes that's going on. In this case, all I'm doing is like just creating a token, which allows these different pieces to go. This is an incredibly safe operation. As soon as I merge that, that's going to go straight to our customers, and our customers can use. Cloud Control API, overall, honestly, it's incredibly good. There are some nuances about what's going on. It mostly has all the data that we need to make great decisions, but the fact that it uses the CloudFormation specification is a bit of a genius idea by Amazon, because that is a specification that's been around for a long period of time. Missing discovery and import for some of our assets is super painful, but we have workarounds for that, except CloudFormation. CloudFormation doesn't have import. Okay, there is a CloudFormation import, but all that does is just import the stack. Okay, or import the template. It doesn't import the individual resource. So for example, we would need to know the specific IDs to import that into System Initiative and then manage it in a different way. And then lastly, the ability to override any of our assets, to delegate that to CLI, API, SDK to get more rich information is incredibly valuable. Thank you so much. I've rambled for like a long time. I didn't mean to ramble this long, but yeah. And if you have any questions, there's probably no time, but you can find me. I'll be eating pizza and drinking beer.